All right, in this lesson, we are going to talk about how to factor polynomials using synthetic division. Okay, we're going to start by reviewing how to factor our special cases. And so looking at number 1, I recognize that it's a trinomial going from degree 4, exponent 4, to 2. Since that's a 2-to-1 ratio, I know I can use u substitution with u equals x squared, because then u squared would be x to the 4th. Okay, and so I can replace x to the 4th with u squared, x squared with u, and then I just have a quadratic to factor. And so looking for two numbers that multiply to negative 56, but add to negative 1, that would be negative 8 and 7. And so this factors to u minus 8, u plus 7. Okay, and so since u is equal to x squared, now I can replace it with the x squareds. And both of these are prime. They are not a difference of squares, and they are only two terms. There's no GCF, and so there's nothing left to do. And so it's also a great idea to check. X squared times x squared would give me x to the 4th. Negative 8 times 7 would give me the negative 56. So do a quick spot check to make sure that you have a reasonable answer. Okay, for number 2, I see 4 terms, and so I always try to factor by grouping. And so split it down the middle. Out of the first pair, they have a 5, and they both have an x cubed we can divide. Okay, and so 5x fourth divided by 5x cubed is 1x, and then 5x cubed divided by 5x cubed is just 1. Okay, here the leading term is negative, and we can also divide out a 3, and we can also divide out an x. Okay, and so that would leave me with x and then plus 1. Because my parentheses match, that means everything is good. That means x plus 1 is one of my factors, and the other factor comes from the 5x cubed minus 3x. Now, you're probably noticing that my second factor still has a GCF. I can factor out an x. And so you could have either done that from the very beginning, or you can do that now. Just don't forget to do it. And so we should factor that x out to the very front, followed by the x plus 1. And then that would leave me with a 5x squared minus 3. You need to make sure each of your factors only have a constant and not a variable. Okay, and so checking our work, x is linear, x plus 1 is linear, and then 5x squared minus 3, that is not a difference of squares, so that is prime. Okay, and then checking our first terms, x times x is x squared, times 5x squared is 5x to the 4th. And then multiplying the constants, I would have 1, negative 3, and that would give me the negative 3 times the x. Okay, so just quickly checking to make sure you have a reasonable answer. Okay, next up, we have degree 4 going to degree 2. It's a trinomial, and so we could try u substitution, setting u equal to x squared. So that means I have 6u squared plus 11u minus 7. This time our quadratic has an a value, so a times c is negative 42. And we need our numbers to add to 11. Two numbers that multiply to negative 42, but add to 11. And so those numbers would be negative 3 and positive 14. Okay, and so we split up the middle term with those two numbers. So 11u is negative 3u plus 14u. Bring down the constant, bring down the 6u squared, and then now we can factor by grouping. And so in the first pair, I can divide out a 3 and a u, leaving 2u minus 1 Out of the second pair, I can factor out a 7, leaving a 2, put the 7, and then 2u minus 1. The 2u minus 1 matches, which means we're doing everything right. That's one of your factors. The other factor comes from the 3u plus 7. Okay, and so remember, u is equal to x squared. Don't leave the u's in your final answer. And double check, make sure we have prime, so that's a prime quadratic. That's a prime quadratic. We don't have difference of squares. Okay, and then also checking the first terms. 2x squared times 3x squared is 6x to the 4th. Negative 1 times 7 is negative 7. So just quickly checking, make sure it's reasonable. Make sure you didn't forget any GCFs. Okay, looking at this next example, there's 3 terms and we go from 4 to 3. But luckily, we also have an x squared here, so there's a GCF of x squared that we need to divide out right off the bat. Okay, there's really nothing else we can do until we get the x squared out. Okay, and so with that x squared out, I would be left with 8x squared minus 10x minus 3. And now that's just a quadratic. And so a times c is negative 24. And we need 2 numbers that multiply to that negative 24, but add to negative 10. Okay, be careful with these numbers. It's tempting to choose 6 and 4, but those won't work. Okay, 6 and 4, they would have to both be negative to get to negative 10. And then if they're both negative, they won't multiply to negative. And so we actually have to use negative 12 and positive 2. Negative 12 plus 2 would give me the negative 10. Negative 12 times 2 is negative 24. So sometimes it seems like you have multiple numbers that would work, but you don't. Okay, and so we're splitting the middle term with negative 12x and 2x. Bring down your minus 3, bring down your 8x squared. Ignoring this x squared for now, but we'll have to remember to bring him back for the final answer. Okay, out of the first pair, they're both divisible by 4 and x, leaving 2x minus 3. Here, there's nothing in common other than 1, which would also leave a 2x minus 3. The 2x minus 3 matches. That means we're doing everything right. So 2x minus 3 is one of my factors. The other factor comes from the 4x plus 1. And then do not forget your GCF out here. He comes back for the final answer. That way when we check our work, x squared times 2x is 2x cubed times 4x is the 8x to the 4th. Okay, this one I see a difference of cubes. My first term is 2x quantity cubed minus my second term, which is 3y quantity cubed. Okay, and so make a small set of parentheses for the binomial, make a larger set for the trinomial, and then it's same, opposite, always positive. Okay, now that we have the signs in place, we ignore them. This is our A, this is our B. And so remember, A goes here, B goes here, A squared, AB, B squared. So A is 2x, B is 3y, A squared would be 4x squared, B squared would be 9y squared, AB would be 6xy. Remember, ignore the signs. It's always tempting to multiply that negative. Ignore it. You already took care of the signs using same, opposite, always positive. SOAP will help you remember that. And so what you're left with, and as long as you don't have any GCFs, will be your final answer. The quadratic will always be prime. Okay, lastly, we have 4 terms, so let's try to group it. So out of the first pair, I can do 4x squared, leaving x plus 2. Out of the second pair, I can do negative 1. Anytime this is negative, this is negative. And so that leaves behind an x plus 2. The x plus 2 matches. That means we are doing everything right. And then the other factor comes from the 4x squared minus 1. Now we are not done. We have a linear, so he's done, but we have a difference of squares. Okay, that factors to 2x plus 1 and 2x minus 1. Okay, and so now that we have all our linears, we can double check, make sure x times 2x times 2x is 4x cubed. That's what we wanted. All right, so now we need to talk about what happens if it's not a special case. If it's not a special case, you need to be given either a factor or a root, and then we can divide it out. And so that's what these next 4 examples are going to cover. And so here I've got a degree 3, it's got 4 terms, but if I try to do grouping, I could factor out an x squared. Here I can't factor out anything but a 1. And so that would leave an 11x minus 6. This would leave an x minus 6. So these don't match. Grouping isn't working, okay? And so when grouping doesn't work, that doesn't mean it's not factorable. It just means you have to use a different method. And so the only other method we have is to just divide out a given factor. So they told me x minus 3 is a factor. That means if I were to divide this quotient, this polynomial, by the x minus 3, I should get a remainder of 0. Okay, I should not have a remainder. And so we can use synthetic division and see what's left behind. Okay, so using synthetic division, I just get the coefficients of the dividend. We're not missing any terms, so 1, negative 6, 11, negative 6, and seeing those ratios aren't the same, we know grouping wouldn't work. And then remember the root of the divisor goes here. Root of divisor. Okay, bring down the 1. 1 times 3 is 3. Add, we get negative 3. Negative 3 times 3 is negative 9. Subtract or add those and you get 2. 2 times 3 is 6. And sure enough, we have a remainder of 0. Okay, and so what we're left behind with is x squared minus 3x plus 2. Remember, you always drop your original degree by 1 because we divided out a linear factor. And so we have one factor is x minus 3. The other factor is this quadratic. Okay, and so we can factor this quadratic. 2 numbers that multiply to 2 and add to negative 3 are negative 1 and negative 2. So that just factors to x minus 1, x minus 2. Okay, and so that means my factored form is x minus 3 times the x minus 1 and x minus 2 that we just found. Okay, and so x minus 1, x minus 2, multiplying those would get me this quadratic, and then multiplying by the x minus 3 that we divided out would get us back to our original polynomial. Okay, and so this was given, and this is what we found. That would be the factored form. Okay, here, once again, you can tell by the ratios, we have 1 to 1, negative 22 to negative 40. Those are not the same, so grouping will not work. And so here they're telling us negative 2 is a 0. That means x plus 2 is a factor. Okay, if negative 2 is a 0, x plus 2 is a factor. So we know that's going to be in our final answer. This is degree 3, so we're hoping for 2 more linear factors. Okay, this was given. And so now we just need to divide out the factor they told us using synthetic division. Remember the root, which was given, goes here. The coefficients of the dividend go here. Bring down the 1. 1 times negative 2 is negative 2. Add, we get negative 1. Negative 1 times negative 2 is 2. Add, we get negative 20. Negative 20 times negative 2 is positive 40. Add, we get 0. you should get 0 because they're not lying to you. It actually is a factor. Okay, and so drop your degree by 1. That leaves me with x squared minus x minus 20. We can factor that quadratic if we find two numbers that multiply to negative 20 and add to 1, negative 5 and 4. So that factors to x minus 5 and x plus 4. Okay, so those are my remaining factors, x minus 5, x plus 4. Given, found. Okay, and so if we were to multiply all this back, we should get x cubed plus x squared minus 22x minus 40. Factored form has these three linear factors. Okay, this next one says 2x to the fourth minus 9x cubed minus 21x squared plus 88x plus 48. That has 5 terms. There's no way we could factor that using any of our methods. It's not a special case. So they told me 4 is a root with multiplicity 2. That means x minus 4 is a repeated factor. Okay, and so in my factored form, I should have x minus 4, or you could write that as x minus 4 squared. We'll start doing that. And so that will be a good habit for when we start graphing these. This is a degree 4 polynomial, so I should have 2 more linear factors. Okay, and so that's the goal. We have x minus 4, and then we're going to have hopefully 2 other linear factors unless we're stuck with a prime quadratic. Okay, and so starting with synthetic division, let's divide out the factor we have. And so one of my factors is x minus 4. So remember, put the root here. So bring down the 2. 2 times 4 is 8. Negative 1. Negative 1 times 4 is negative 4. Add, we get negative 25. Negative 25 times 4 is negative 100. 88 negative 100 is negative 12. Negative 12 and 4 is negative 48. Okay, so we get a remainder of 0, but remember, this is a repeated root. And so if I divide by that factor again, putting that root here, we should get 0 as a remainder one more time. So 2 times 4 is 8. Add, we get 7. 7 times 4 is 28. Add, we get 3. 3 times 4 is 12. We get a remainder of 0. So 4 got divided out twice. And so we can just stack them and continue, because these are the coefficients of the quotient, and then we just divide it again. Okay, and so now my coefficients, we need to drop the degree, which was 4, by 2, because we divided out 2 factors. And so that would be 2x squared plus 7x plus 3. So that's a quadratic. We can factor quadratics. A times c is 6, and we need them to add to the middle number 7. That would be 1 and 6. A is not 1, so we have to split the middle. And so when I split the middle with those 2 numbers, I can get an x out of the first pair, which leaves behind a 2x plus 1. I can get a 3 out of the second pair, which leaves a 2x plus 1. The 2x plus 1 matches. That means we're doing everything right. The other factor comes from the 3, the x and the 3, in that order, x plus 3. Okay, and so those are our other factors, 2x plus 1, x plus 3. This x minus 4 squared was given to us. This 2x plus 1, x plus 3 is what we found after we divided out the given factors. Okay, and so for this last one, we have a degree 4 polynomial, and we are given that x plus 2 is a factor. Okay, and so since it's degree 4, x plus 2 is one of the factors. We're hoping for 3 more linear factors. Okay, and so let's go ahead and divide that out. The root would be negative 2. coefficients are 3, 5, 1, 5, -2. Again, this is 5 terms. We don't have a special case for that. Bring down the 3. 3 times -2 is -6. Add, we get -1. -1 times -2 is 2. Add, we get 3. 3 times -2 is -6. Add, we get -1. -1 times -2 is +2. Add, we get 0. So we did that right. Got a remainder of 0. And so if you notice these coefficients, the ratio is the same. And so I already know that I'm going to factor this by grouping. Okay, and so remember, drop your degree by 1. That would be 3x cubed minus 1x squared plus 3x minus 1. And 4 terms, we can try to group it. And so out of the first pair, I can get x squared, leaving 3x minus 1. Out of the second pair, just a 1, leaving a 3x minus 1. The 3x minus 1 matches. Means we're doing everything right. And then we have an x squared plus 1. That is not a difference of squares. We're not going to be able to factor that. And so be careful. When it's a plus sign, it's prime. Okay, and so we didn't get 3 linear factors, so the completed factored form would still have that prime quadratic in it. And so we would have the 3x minus 1 and then the x squared plus 1. And so this part was given, and this is what we